Hey guys, I hope that I'm live right now. If you guys are able to listen to me properly as well as there's no issues with the audio or the video, please let me know. Hello everyone, I hope that I'm live right now. If you guys are able to listen to me properly as well as there's no issues with the audio or the video, please let me know. Okay, no issues, right? Great guys, great. Good evening everyone, good evening, good evening. I'm so sorry I was a bit late. I was stuck in the traffic right now, so I was not able to arrive to the office on time itself. But no issues. We'll start with the class immediately without wasting any time. Okay. So can you guys let me know what have we learned in our yesterday's class? Could you guys let me know what have we learned in our yesterday's class? Could you guys let me know what have we learned in our yesterday's class, guys? Good evening, everyone. Good evening. Could you guys let me know what have we learned in our yesterday's class, guys? Bar graphs. Okay, good. We saw about how to change the color as well. Good. We saw adjusting colors for graphs. Good, guys. We also saw about how to make sure that if we want it in a particular order, according to the greatest, like the in a descending order, we saw that as well. We saw the ticks if they're colliding with each other, how to change the rotation of the ticks, as well as how to change the axis for plotting purposes. We saw that, right, guys? Good, good, great, guys. Amazing, amazing. Okay. Okay, so no doubts up till this particular point of time, guys, right? No doubts up till this particular point of time. Please let me know. No doubts, right, guys? Great. So we'll continue from right over there itself, guys. Today we are going to go over the second particular topic itself. Okay. No issues. Good. So what we are going to do right now is that we are going to go over the second particular module. We'll start with the next particular thing itself. For those guys who missed out yesterday's attendance, the yesterday's attendance is still open. OTP. So yesterday's attendance is still open, guys. You guys can go ahead and watch the entire video and write, like fill up your attendance itself. I've not closed down the attendance. Just a second. 75 641. Hey, shit. 75641. Okay, great, guys. So we will start from right over there, guys. We'll start from right over there. Okay, and let's continue. So let me open up the today's assignment. So it's not today's assignment, the today's notes itself that we are going to utilize. So this is the video that you are currently watching. Okay, this is the video that you are currently watching, guys. If you go to the description of the video itself, there in the second link for notes. Okay, you are having this notes link. We are going to utilize the second link for notes itself, guys. So if you click on that, it will open the notes for you. And what we want to do is we want to select the date 12 of data visualization. Okay, date 12 of data visualization, not anything else, guys. Date 12. So once you're selecting date 12, your notes will open up for you guys. As you're able to see, you're going to see histograms, you're going to see pie charts and everything today, and some other things as well. It will be very simple for us. Later on, what we want to do is we want to open up Collab. Okay, oh, not Code Sandbox, Collab, sorry. This is what happens when you're switching with web development and data science altogether. Okay, so opening Collab, I was opening up Code Sandbox. We're going to go to GitHub. We're going to copy the link or URL for our date 12 data visualization. We are going to copy that, and we are going to paste the link right over here. So we are going to remove this. We're going to paste our link, and then we are going to click on this search button. Okay, we are going to click on this search button, guys. That will open up your notebook inside of Colab. You're going to click on connect. So it will connect us to the servers at Google Colab itself. Okay. Can you, sir, can you share yesterday's attendance link? Tarun, you'll have to watch the entire video to get the link. I won't be sharing it anywhere. Otherwise, what's the point of conducting classes if you're not watching the classes? Okay. So, yeah. Oh, Tarun is a fast replier. He replied so fast. Thank you so much, Tarun. Okay, usually I'm just waiting for the person to reply. Okay, great. Rajendra, sir, please respond on LinkedIn. I'm so sorry, Rajendra, for a long period of time, I have not opened up my LinkedIn account itself. As you're able to see, there's some 88 pending requests and some 37 messages that I have to cater to. I will definitely do that in 1 or 2 days itself, guys. Just give me a few days. I'm actually a lot busy with a lot of project works that I'm having. So then we are going to go to files, okay, and we are going to upload our Pokemon.csv. I've told you guys where to find the Pokemon.csv file. We are going to upload it right over here. I'm so sorry. So we have uploaded our dataset that we are going to use. We are going to sir, your notes are superb. Thank you so much, Kunal. So guys, have you gone through my notes or not, guys? Let me know, like, if you have gone through my notes or not. Like, oh shit, I'm so sorry. I've created some notes for you guys, right? Have you gone through that notes up till now or not, guys? Python for data science. Like, I've created some 15 days worth of notes for you guys just on Python. Okay. If you ever want to start with Django, if you want to start with data science at any particular point of time, then go through these notes. Soon I will be uploading my notes for machine learning as well. I showed you guys, right? So the notes for machine learning, I'm creating I'm creating it. I can show you guys that as well. So I will be starting to upload my notes on machine learning very soon. As you're able to see, I've written a lot. Like, there will be some images, there will be some videos as well for you guys. There'll be a lot of coding. Okay, there'll be a lot of coding that will be there. Okay, all these subfields, like proper explanations for everything that you have to learn at any particular point of time. So prerequisites, I've already made it right over here, but I will be creating more prerequisites as well. And the entire thing that I've created, all these notes, I've created it in such a way that you guys will be working as a data analyst on small projects to understand the concept of how a data analyst actually works. So exploring the data set, then you are having like measuring success, training and testing data, inspecting the data, okay, modeling to welcome to linear regression. I'll be it's still a pending work itself. I am trying to write it in a very simple manner so that everybody is able to understand it no matter what background they are from. So it will take me some time. I'm trying to make sure that mathematics is also included right over here. I'm trying to make sure that code is also included. You are getting the intuition of the algorithm. You are understanding the mathematics behind it. You are able to implement the algorithm as well, both on a trial data set as well as on a production data set as well. So all these things will take me some time to actually complete it. And as you're able to see, there's a lot of mistakes, parameters, so spelling mistakes are there, grammatical mistakes are there. I'm not very good with writing, but let's hope for the best. At the end of the day, you can continue with the Python that I've already provided to you guys. Okay, as soon as my machine learning part is getting done, I will start pushing that up as well. Give me some time so that I'm able to do that for you guys. Okay, no issues. We'll start with our project right over here, guys. And at any particular point of time, do let me know if you guys need something from me. Okay, so for YouTube as well, I'm not getting time to actually create something live itself, but yeah, I'll try to make something for you guys according to your requirements. After these live days, will notes will be available on YouTube or you will remove it? Amina, if you know me up till now, you will know that the notes will always be available for you guys. Okay, we are never taking it down. These videos will be always available for you guys. We are never taking it down. Okay, because that is something that is my personal hard work, and I never charge for my hard work. Like, I will always make it free. You don't have to worry about that. Okay, so let's get started with that, guys. So first we'll be importing all our libraries that we want: NumPy, Pandas, Matplotlib, Seaborn. Okay, so that is what we'll be doing. Okay, and next we are going to import our data set as well. We have already seen that yesterday. Okay, this time we are naming our data set as df. Okay, we are going to name this particular data set as df, guys. Okay, so data frame, that is the full form of df, data frame, guys. So the format that this CSV is getting converted to using read CSV from pandas is basically called as data frame. Okay, and that is the format that Python can easily interpret, okay, easily used as well. So that is the reason why we are using a data frame format itself. We have already done this yesterday, so we can directly jump off to pie charts. I don't think so we actually need a particular answer. So what is a pie chart itself? I think so the name itself tells us that it's a representation as a whole. Okay, whenever something is as a whole, as a community, you're trying to represent it in ratio intervals, again ratio data itself. That is the point of time you will be using pie charts. I've already given you an assignment on trying to identify what is the difference between a ratio as well as a interval data set. Okay, try to find it out, guys. Okay, still I'm not taking up, see, these assignments are meant to be an extracurricular thing for you guys. Okay, you don't have to do it. Okay, I'm not going to ask you to submit your assignments or something like that. I'm never going to do that. Assignments, I give it to you guys because I don't have the time to actually check it. That is the main problem. But I gave you these assignments so that you guys are able to enhance your knowledge. Okay, the more that you search on the internet, the more that you learn. Instead of spending like hours and hours on TikToks, you can actually do something productive during that point of time. That is the reason why I'm giving you assignments as well. Try to make sure that you are doing the assignments. Okay, so right over here, as you're able to see, this is an example pie chart. A pie chart can be represented as a count plot as well. On the right hand side, you are able to see a bar graph, a count plot, okay, of the same information that is represented as a pie chart on the left hand side. Now sometimes pie charts are very hard to actually like understand. So we are able to see that beta is the largest, then comes the gamma, then the alpha, and then delta. Okay, so this pie chart we are able to see that, okay, this is the kind of differentiation that is there, but usually it will be pretty hard to spot on. So using pie charts, there are very few places where you will be using pie charts where you are actually able to find the ratio between the stuff itself. That okay, so these four things, alpha, beta, gamma, and delta coming together, it is able to form a plot itself. So just like this alpha, beta, gamma, it's basically our campus ambassador program itself. This is the current count of the people in the beta program, the gamma program, the alpha and the delta program itself. So this is a live data that we have taken up from our campus ambassadors of DevTown, and we have converted it into a pie chart and a count plot so that you guys are able to see it. Okay, so that is how you guys will be able to identify it as well. Are you able to understand this? Please let me know. Okay, so I am not going to explain you how a pie chart basically works because I am able to understand that most of you guys have made a pie chart at some particular point of time. Even if you have not made a pie chart, maybe you have cut a cake itself. Okay, so cutting a cake, so you are going to get like this much portion of the cake. You are going to get like just one piece of the cake itself. That is might be something that you have done at some particular point of time. Okay, so we'll directly go into our how to create a pie chart itself. So first of all, this is what we have seen yesterday as well, value counts. Do you guys remember that? df.generation id value counts. Do you guys remember? Let us just recode it once again to see if you guys remember it or not. So this is the value counts that we are getting. So generation id 5, you are having 156 Pokemons of generation id 5. Then generation 1, you are having 151 Pokemons. Generation 3, you are having 135 Pokemon. So this is all that we have seen yesterday. This is not something that we are doing today itself. Okay, so once we are able to understand that, that is how we are going to create the pie chart as well. The plt.py is the format that we are going to use. Okay, pi is the basic attribution that we are going to use right over here, that is going to help us create our pie chart. Okay, we are going to fit in our sorted counts that we have created right over here. Sorted counts is df.generation ids.value counts. We have seen that yesterday. Okay, we have seen that yesterday and we're going to use that right now. Labels we are going to identify as dot index. Okay, sorted count dot index, so that basically gives us dot index. Okay, so if we are checking this up, you're able to see that it is giving us the index of that entire data. Okay, 5 1 3 4 2 7 6, these are the indexes of the generation IDs that we are going to use. Okay, start angle is equals to 90. So basically it tells that when you're creating the pie chart, it will start from the 90-degree itself. So from right over here at this particular angle itself, you are going to create the entire thing in a clockwise direction. Okay, so for example, the first particular ID that we are having, if you are able to see right over here in value counts, the first particular thing that we are having is index 5. Okay, that is generation ID 5 is having 156 units inside of it. 156 Pokemons. The first particular ratio, first particular attribute of the pie chart will be starting from 90, 156. Okay, starting off 90, 156. Okay, are you guys able to understand this? Please let me know. The next particular thing will be 151 generation ID 1. So next particular thing will be 151 generation ID 1, and so on and so forth. Okay, are you guys able to understand this particular concept? What is the start angle 90? Okay, that is, you want to start the counting from here and go in the clockwise direction. Okay, that is the reason why we are writing right over here counterclockwise is equals to false. Okay, that is, we want to go into the clockwise direction. Okay, the plotting should be done in the clockwise direction. That is the reason why we are writing right over here counterclock is equals to false. This attribute will make sure that your plotting is happening in a clockwise direction itself. And because we don't want our pie to be distorted, okay, we want our pie to be a circular in nature itself. We don't want it to be oval or something. Okay, so for that particular thing itself, we are going to put up plt.axis square. Okay, it will make sure that the axis of our plot is square itself. That is, our pie chart will be a proper circle. It won't be distorted like an oval or something. To make sure of that, we write this as well. That is plt.axis is square, guys. So if I'm running this particular line of code, you will be able to see that we are plotting our chart itself. The first 5 is coming, then 1, then 3, then 4, then 2, then 7, then 6. Okay, that's the exact ratio in which we are having our generation ID dot value counts. That is our sorted counts itself, because it is already sorted in nature, right? We saw it yesterday that dot value counts basically sorts it out as well, descend in the descending order. Okay, so we are going to use that, and that is the pie chart that we are able to obtain. Okay, that is the pie chart that we are able to obtain, guys. Okay. So what if sometimes you want a donut chart? Okay, not always you want an entire pie graph itself, right? Many people don't prefer cakes, many people prefer donuts itself. So one of its just a variations for your pie chart is your donut chart. Okay, so basically, as the name suggests, it has a hole in the middle. That's the only difference. Okay, so it has a hole in the middle itself. To be able to create that, it's pretty simple. You are still going to use the exact same things. Okay, up till here everything is the same. Okay, we are not changing anything up till here. The highlighted portion is the exact same thing. We are not changing anything in the highlighted portion. It's the same code as pie chart. We are adding another attribute to it. Okay, we are adding another attribute to it that is called as the wedge props. Okay, that is called as the wedge props, guys. Okay, the web prop sorry, I might stutter a bit. I've been talking since the morning itself. So wedge props, as we are able to see right over here, is basically adding up width is equals to 0.4. Okay, width, let's convert this width to 0.1. Okay, width is equals to 0.1, and let's save it. Okay, sorry, let's just save it. Okay, and we'll run this line of code. As we're able to see, whatever width that you are mentioning right over here, that will be the width of your donut. Okay, do you want the donut to be pretty thin in nature? Put a smaller name. Okay, if you want it, so basically this is on the ratio of its radius. Okay, so if I'm putting up it to be width is equals to 1, I will get an entire like pie chart itself. Okay, that means the width of the donut is equivalent to the radius of the circle itself, of the pie chart. Okay, the width of the donut is equivalent to the radius of the pie chart. So if width is equals to 1, that is, it is equivalent to the radius, so you get a complete pie chart itself. If I'm putting the width as 0.5, that means the width of our donut is 0.5 times the radius. Okay, so you will get a donut that is 0.5 times the radius itself. So you can change this particular number of the wedge props to make a donut. Okay, to make a donut itself. If you put 0 right over here, you will get nothing. Okay, if you put 0, that means there's no width to your donut itself, so it's an empty plot. But if you're changing it to 0.01 or something, you will be able to get like a thin line. Okay, you'll get a very thin line right over here. Okay, are you guys able to understand this? Please do let me know. Wedge is an English term. Okay, wedge is an English term that basically means wedge. Okay. It's an English term itself, and props means it's attributes that you want to have. So what is the attributes of the thickness of the wedge that you want to create? Okay. Guys, you're so intelligent, man. You guys were able to understand that in just one go. Great. I'm going to die someday drinking all this Pepsi. Okay, the next particular type of graph that we are here to learn is histograms, guys. Histograms are very famous. You guys must have done histograms all the time. You must have been very confused between what is a histogram and what is a bar chart. Okay, that was happening with me when I was small. Okay, I didn't used to like, I was not able to distinguish between a histogram and a bar chart. Okay, so what happens if we give 2? Sort of, let's check it out. Okay, let's check it out if we give 2 as the width itself. Okay, so it will basically overlap with each other. Okay, your pie chart will overlap with each other itself. So if you are giving a width of 2 itself, it will just overlap with each, the colors will just overlap with each other, and you are not able to understand anything out of this type of graphs itself. So always make sure that you are not doing anything like that. Always make sure that the numbers are within the parameters itself, so that you are actually able to get a plot, a defining plot itself. Okay. Okay, so I was always very confused between histograms and bar charts. Okay, because their use was the absolute same. The only thing that I was able to identify was, okay, bar charts had some space in between two bars. Histograms don't have any fucking space between each other. Okay, but yeah, that is not the case, right? There's a huge difference between bar charts and histograms. Let me just delete this entire thing and let me help you guys out with the understanding itself. So your bar charts is usually a defining thing for categories that you want. Okay, for example, you are having a category of let's say 10, 15, 20, 30. So these are the categories that you are having. In 10, you are having like some 20 counts. Okay, 15, you are having some 30 counts. Okay, 20, you are having some 5 counts. Okay, 30, you are having some like 50 counts itself. Okay, and you're like plotting this count. Okay, you're just plotting that count. Okay, that is basically what a bar chart is. That is basically what a bar chart is. You are having this bars and you're having this 10, 15, 20, 30 right over here. For 10, you are having some 20. For 15, you are having some 30 counts. Okay, something like this. For 20, you are having just 5 counts or something like this, a small ass one. And for 30, you are having some 50 counts. So you are just going way above the same. And this is the bar chart that you are able to obtain. Okay, this is the bar chart that you are able to obtain, guys. Now that is what bar charts are. Okay, you have categories in that. You have counts of each of these categories. But when it comes to histograms, okay, it is a continuous distribution of numbers. Okay, it's not always going to be just 10, 15, 20 and 30. The number can be 11, the number can be 12, the number can be 10.5, the number can be 10.43125, the number can be 0, the number can be 123 as well. So numbers can be anything. Okay, the plots that you are able to have, and you cannot plot for every single number, right? You cannot count for every single individual number itself. So for that particular reason itself, you have something called as histograms. Okay, in histograms, the numbers won't be like you have 10 counts, or sorry, you have 20 numbers of 10. Okay, you have 30 numbers of 15. Okay, this is not going to be the case. Okay, you are going to have like 11, 15, 10.15, 0. You are going to have 3.14, 3.26. So you're going to have a distributed array of numbers. Okay, it is going to be a distributed array of numbers itself. So instead of counting okay, how many 11s are there, how many 3.14s are there, what you're counting is interval data. Okay, what you're counting is interval data. So how many plots do we have? How many points do we have between 10 to 20? Okay, how many counts we have of numbers that range between 10 to 20? So between 10 to 20, we are having 10.15. We are having 15. So we are having 2 counts. Okay, we are having 2 counts of data that are in between 10 to 20, and you're going to plot that accordingly. So between 10 to 20, you are having 2 data that is there. Between 20 to 30, you are having 1 data that is there. Between 1 to 10, you are having 3 data that is there, and so on and so forth. So that is how you count a histogram. Histogram is a continuous distribution of data. Continuous distribution of data, guys, and that is the use case of histograms. Are you guys able to understand histograms, guys? Please do let me know. This is the only graph that I've explained. Okay, this is the only graph that I explained because I thought that it needed some explanation behind it. Are you guys able to understand this? Please do let me know. Great, guys. Awesome. So let us go back. Let us start to plot it out as well. So to plot a histogram, it's pretty simple. It's just hist. Okay, that's the plot. Let's go back to our data itself. We are going to plot our speed data. Okay, as you're able to see, speed is a distributed data. You're having 45, you're having 60, you're having 80, you're having 65, you're having 80 right over here. It's a distributed data. It's not a very simple data that we are having. Even if we go back to our code itself, if we go back to our data set and we open it into Excel sheet, let me just zoom in a bit. Let's zoom in it a bit. As you're able to see the speed data that you're able to have, they're like 43, 58, 78, 45. Okay, so you're having 70, 101, 72, 97. So you're having this distributed data itself. 56, 76. Okay, 35. It's not just in tens of fives itself. You're having a distribution of data. Okay, you're having a distribution of data itself. So this distribution of data is what you want to plot right now. And that is the reason why we are choosing a histogram. Okay, that is the reason why we are choosing a histogram. To plot it, it's very simple. Hist. Okay, data. Which data do you want to use? So we are going to use the DF data. Okay, that is the data frame. That is the Pokemon data set that we have created. And on the x-axis, we want the speed to be there. Okay, on the x-axis, we want the speed to be there. So what it does is, it will take up the minimum number. Okay, 31 is the number that is the minimum. Okay, and 60 is the one that is the highest number itself. 160. Okay, that is the highest. We will divide it into equal parts. Okay, 31 to 60, it will divide it into equal parts. So the first particular so if you are going it to right over here, okay, you are able to see that you are starting out with something very near to like 10. Okay, you're starting out with 10 itself, and then from 10 to 20 you are having the first batch, then 20 to 40 you are having the second batch, and so on and so forth. So these batches, you are not able to identify it actually. Like if you see this, you're not able to identify where is the batches. Okay, the first batch that you're able to find is 5 to 20.5. Okay, that is the first batch. Okay, 5 to 20.5. 5 is the lowest number. Okay, 5 is the lowest speed that is there. Okay, and it is going till 160. So 5 to 20.5, that is the first batch. Then 20.5 to 36, that is the second batch itself. Then you are having 36 to 51.5, then 51.5 to 67, then 67 to 82.5, then 82.5 to 98, then 98 to 103.5, then from 103.5 to 129, then from 129 to 145, 144.5 itself, and then the last one is 144.5 to 160. And the number of counts in each of them, you are able to see the first count is 31, the second particular count is 96, the third count is 163 Pokemons. Okay, the fourth particular count is 159 Pokemons that are there, and that is the representation of it in a histogram. Okay, this data has been represented in a histogram. All this division, okay, that okay, the first particular batch should be of 5 to 20.5, and all these has been done by the plt.hist method itself. Okay, has been done by the plt.hist method itself. Are you guys able to understand this? Please let me know. Are you guys able to understand this? Please do let me know, guys. But sometimes we want it to be a little bit different. Maybe I just want 10 histogram bars itself. Right over here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. Okay, maybe I want 20 bars. Okay, I want 20 bars. I don't want 10 bars. I want 20 bars. So what to do in that particular case itself? Okay. So for example, right over here, we have specified 20 bins. Okay, it is called as bins in histogram. These bars in bar charts are called as bars. In your histograms, they are called as bins. Okay, because that's the range of values that are having. So one bin is there. So right now, by default, it is 10. Okay, by default, the number of bins that are there is 10 itself. I want 20 bins. Okay, I want 20 bins. So we'll take up the minimum value. The minimum value is 5. The maximum value is 160, and we'll divide it into 20 bins itself. It will divide it into 20 bins and make the counting on the basis of that, and then it will pop like print it out. So this is how the entire plot would look like with 20 bins right over here. As we are able to see, the number of bars are much more than before. The number of bars are much more than before itself. What is the array values? That is what I said right now. The first array values is the number of items in each of these bins, in each of these 20 bins. And the second particular array value represents the number, the range of each of these bins itself. Range of each of these. So first bin is from 5 to 12.75. The second bin is from 12.75 to 20.5, and so on and so forth. That is how it works, guys. Okay, and that is what you are getting right now. Now I want to differentiate it a little bit. Okay, I want it to be differentiated a little bit itself. Instead of having the number of bins fixed, okay, instead of having, okay, so I want 20 bins. Okay, so as you're able to see in this 20 bins, the range is very like very different. Okay, very like awkward itself. 5 to 12.75, what does that mean? Okay, usually if I want to create bins, I will be creating them as, okay, from 5 to 10, then 10 to 20, for 10 to 15, then 15 to 20. I want bins like that. Okay, I don't know how many bins, but I want bins like this itself. Okay, so let us try to understand this. Okay, this is a mathematical statement. It's not actually a statement that you need programming to understand that. For example, right now we know that the minimum amount is 5. Okay, the minimum amount is 5. The maximum amount is 160. I want to create bins of this particular number. Okay, so 5, then 10, then 15, then 20, then 25, up till 155, 160. I want to create bins. So how many bins will be there, guys? Okay, how many bins will be there? Okay, how many bins will I have to create? Okay, where the bins is equals to what? Okay, I have to specify this. Okay, I have to specify this, guys. So that is what we want to understand. Okay, that is what we want to understand, guys. What we will be doing is we will be calculating that. Okay, we'll be calculating that. To calculate it, it's actually pretty simple. Basically, we want this array. Okay, we want this array, as you're able to see, 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, and so on and so forth up till 160, guys. Okay, up till 160. We want these bins to be there. Okay, to create these bins, what we are going to do is we are going to use np.arrange. Okay, that is a numpy function, right? Like I said, okay, do you guys remember why numpy is used? Can you guys let me know? I've told you guys, right? Why numpy is used? Can you guys let me know? Can you guys let me know why numpy is used? That's absolutely correct for mathematical expressions, for numerical, but for what, guys? Mathematical numerical operations on what? Okay, my question is numerical calculations on what, guys? Matrices. Rajendra, you have correctly answered it. It's on matrices, guys. Okay, not as what is matrices? Okay, it is basically 1D array or 2D array. Okay, it can be like a particular line, or it can be in 2 dimensions as well. These are matrices. Okay, so right now we want to create this array. We want to create this one-dimensional array, one-dimensional matrices itself that has numbers from 0 to 160. And to be able to do that, this is what we are going to do. Okay, so numpy.arrange is a particular numpy function that creates a array for you. Okay, creates a one-dimensional matrix for you. And the numbers for that, the lowest number should be 0. Okay, the lowest number should be 0. The maximum number should be whatever the maximum is. Maximum speed is plus 1. Okay, whatever the maximum speed is plus 1. So df.speed, that is the speed column. Okay, that is the speed column, guys. Okay, we are having, so if we are putting it out right over here, df.speed speed, and we are running this particular, sorry, I'm so sorry, df and then speed speed, and we are running this particular line of code. As you're able to see, we are getting the speed column from our data frame itself. We're getting the speed column from our data frame. We want to get the maximum, okay, the maximum value from this column. Okay, we want to get the maximum value of this column, guys. So that will be dot max. Okay, that will be dot max, guys. And if we are running this particular line of code, we are getting that the maximum speed, okay, the maximum speed is 160. Okay, the maximum speed is 160, guys. Now let us try to create our own np.arrange arrange. Okay, we want to start from 0, we want to go up till 10. Okay, we want to go up till 10, guys, and we want to increase this step by 1. Okay, we want to plot all the even numbers. Let's assume we want to plot all the even numbers between 0 and 10. Okay, we want to write all the even numbers between 0 and 10. So we are going to write the starting point. The starting point is 0. Okay, we are going to start our counting from 0. We are going to go up till 10, not including 10. Okay, we are going to go up till 10. We are not including 10, guys. To go up till 10, and each step should be of 2 counts. Okay, each step should be of 2 counts. So the first number is 0, then the second number will be 2, the next particular number will be 4, the next particular number will be 6, then 8, and we are not going to include 10. We are not going to include 10, guys. So if we are running this particular line of code, you are able to see that we are getting an array. Okay, I got some okay, it's just 1 hour. Okay, I put 2 hour right over here. It's a range. Okay, not a range. Okay, it's just 1 hour right over here. As you're able to see, we are getting 02468. We are getting 04268. But right over here, we know that the maximum value is 160. Okay, we know that the maximum speed is 160, guys. So we want to include 160 in our calculations as well. We want to include 160 into our calculations as well. That is the reason why instead of just writing, so, and we want to increase our step by 5. Okay, we want to increase our step by 5. We want to go up till 160. So if I'm just writing 160 right over here, my 160 won't be included in my calculations. Okay, 160 won't be included in my calculations. So I'll be going up till 161. Okay, I'll be going up till 161 because 161 won't be included, but 160 will be. So I'm running this particular line of code. As you're able to see, we are getting an array starting from 0, 5, 10, 15, 20, the array that we wanted. Every bin is of 5 digits. Okay, every bin is of 5 digits. And this 160, we are getting it from df speed dot max plus 1. Okay, max, whatever max value was there, plus 1. Okay, whatever max value was there, plus 1, guys. Okay, so that is what we are doing right over here, and we are assigning it to bin. Okay, bins right over here. If we are running this particular line of code, you are able to see that now we are getting the bins of 5. Okay, so from 0 to 5 there is nothing. From 0 to 5 there is nothing. From 5 to 10, 5 to 10 is something. Then from 10 to 15 there's something. And these counts you are able to get it from right over here. So as you are able to see, from 0 to 5 there's nothing. From 0 to 5 the count is 0. From 5 to 10 it is just 3, then 4, then 11, and so on and so forth. So this is how you are able to do a new type of plot. Okay, this is a more generalized version of the plot itself, guys. Now look at this particular plot. Okay, so why don't you increase the number of bins to, let's say, 100? Okay, so if you're doing that, then your histogram is no longer a histogram. Okay, right? It's a count plot. Okay, it's a count plot. You're not able to understand any kind of information about from this type of plot itself, right, guys? If you're increasing the counts to 100 or 150, number of bins, okay, number of bins to 100, 150, 200 itself, then you're not able to get any information out of this type of plot itself. From here, when you're having these bins type of structure, you're able to find out that most of the Pokemons, okay, most of the Pokemons lie between your 30 to let's assume 75. Okay, most of your Pokemons lie between 30 to 75, and then again from 80 to 115. Most of your Pokemons are lie in that particular range itself. But looking at this particular plot where there are like 150 or 200 bins itself, you're not able to get any information out of this. Okay, you're not able to understand anything out of these itself. Okay, so that is why, like, you shouldn't use excessive number of bins. Okay, you should always use enough so that you are able to extract some information out of the plot itself. Okay, you are doing plot basically to understand some intricacies about the data. Okay, so that intricacy shouldn't be lost. Okay, are you guys able to understand why shouldn't we use like 100, 150 bins itself? Please do let me know. Are you guys able to understand that? Please do let me know, guys. Okay, just one second, guys. So Sasi, could you let me know what was the deadline of the Instagram clone? Sasi, could you let me know what was the deadline of the Instagram clone? Sasi. I'm so sorry if I'm butchering your name, but could you let me know what was the deadline for Instagram clone? It was today, right? Today was the deadline. So if today is the deadline, then I will look at the projects from tomorrow morning. Okay, because today is the deadline. So let everybody submit the projects. Okay, let everybody submit the projects by midnight. Then I will start looking at the projects from tomorrow morning itself. And from tomorrow till 5 days, we will be sending out the certificates. Okay. So from tomorrow onwards till 5 days, we'll be sending out the certificates. So it will take me 5 days to actually go through every single project. I start looking at the projects only after the deadline submission. Okay, because before that continuously projects are coming in, so it does not make any sense. So I'll just wait out till the end. So because some people want to change their projects and everything, so we have given them the privilege of doing that as well. So tomorrow onwards, we'll be starting out with checking the projects and sending the certificates. It will take us 5 to 6 days to do that. Okay. Great. Okay. Now we are going to use another plot. Okay, this is another approach by using Seaborn. So the current plot that we were plotting was using your like matplotlib itself. We were using matplotlib. Right now we are going to do the exact same thing, histograms using Seaborn. Okay, we are going to do histograms using Seaborn itself. Are you guys able to understand this? Please let me know. Up till now we were using PLT, right? Up till now we were using plt.hist. That is our matplotlib, guys. Okay, now we are going to use our Seaborn. Okay, we are going to use our Seaborn, guys. So in Seaborn it is called as this plot. Okay, in Seaborn it is called as this plot. And as you're able to see, it is as simple as just like plotting sb dot. Give me a second, guys. Okay, so we are going to use this Seaborn itself, guys. Okay, so right over here, sb.displot is basically Seaborn like a Seaborn version of histogram itself. You just have to specify which particular column that you want to work with. Okay, so you are going to have this df speed. Okay, df speed itself, and if you are running this particular line of code, you are easily able to get the plot, as you are able to see right over here. Okay, so you're getting the plot, histogram plot as well, and it is well distributed. As you are able to see, it makes the distribution assume assumptions on its own. Okay, and so the distribution is very perfect. C1 already does that for you, but it is not count, right? They are having speed and then something called as density. Okay, you are having the speed and something called as density on the y-axis. Okay, speed and density. Okay, what is the density? I'm not able to understand that. Okay, so that is where the KDE comes into place, the kernel density estimation. Basically, what it tries to say that all your Pokemons, okay, all your Pokemon that have some speed that is associated with them, the area under this line graph, the area under this line graph that you are able to see should be 1. The area under the line graph should be equal to 1, guys. Are you guys able to understand this? That is what kernel density estimation is. Okay, KDE. And that is the reason why you are having this density right over here. That okay, Pokemon's having a particular speed has a density of this. Okay, that is the probability that okay, this is the probability of a Pokemon having a speed of, let's say, 75. Okay, a speed of 75 will have a probability of 0.01 something. Okay, so that is the basic thing. Okay, so when you are plotting a histogram using a direct distribution of a histogram using Seaborn, it not just plots up. Okay, it not just plots up the actual histogram as well, but it also plots up the KED. Okay, kernel estimation density estimation, KDE. Okay, kernel density. So all the area under this curve, okay, the area under this curve will come out to be 1. Okay, the area under this curve will always come out to be 1, guys. That is the point. Okay, that is the point. So if you go into a little bit of mathematics, okay, you will know that this is very important when you go into statistics and mathematics in a bit future. For our purposes, we just want to, okay, we just want to create our histogram itself. We don't want KDs, okay, we don't want KDEs itself. Guys, the project that I'm talking about is a previous bootcamp. It is not for this bootcamp itself. Please focus upon the current things that are being taught to you. Okay, please be a bit intelligent enough to understand that this is a data visualization bootcamp, not an Instagram clone bootcamp. Okay, so the project that I was talking about was from a previous bootcamp that we had, not of this particular bootcamp. Right now, focus upon what is being taught for you guys. Okay, great. So right over here, to just ignore, if you don't want, okay, if you don't want KDEs, just write KDE is equals to false. Okay, just write KDEs is equals to false. So it will not plot the KDE for you guys. Okay, it will not plot the KDE for you guys, and you'll just be getting a normal histogram itself. As you're able to see, you're having numbers on the left hand side and numbers on the bottom end as well. So you're just getting a normal histogram. For doing that, just write KDE is equals to false. You don't want the KDEs at any particular point of time itself. Okay, are you guys able to understand this? Please do let me know. So if I want to change some colors or something like that, the same thing. Okay, bins, if you want to change the number of bins, just put up the bin edges. Okay, we have already discussed upon this. Okay, 0 to 161 in terms of 5. Okay, KD is equals to false. Okay, but in histograms, instead of changing colors, you change the opacity of the like histogram itself. Right over here, as you're able to see, this is like a little bit translucent. Okay, the plot that you are having is a little bit translucent, guys. So you change the opacity of your entire plot. Okay, you want to make it a dark blue, you want to make it light blue itself. So change the opacity of it, okay, the translucency of it itself. To do that, just like you're having the his KWS, okay, alpha is equals to 1. Okay, alpha is equals to 1. So that means you are having the entire plot as opaque, okay, entirely opaque itself. So I'm running this particular plot, you are able to see that the plot that I'm getting, the exact same plot I'm getting as opaque. But if I'm changing it to 0.5, okay, if I'm changing it to 0.5, it gets translucent. Okay, it gets translucent, guys. As you're able to see, it's translucent in nature. I can change it to even more, like at 0.1, it will be very light. Okay, so you are not able to see it as well, but it is still there. It is still there itself. It's very light. Okay, I can increase it to 25. Okay, 0.25. So you will be able to see a little bit. Okay, so you can change the translucency of it. Okay, KD is kernel density estimation. Okay, KD is kernel density estimation, guys. Okay, so that is how you can work with right over there. So this alpha is associated with the dictionary to hist KWS. Okay, so all these different things. Okay, because when you're basically creating the histogram, the main focus is on the KDE, the kernel density estimation. Okay, KDEs that we were seeing right over there, density estimations itself. Okay, are you guys able to understand this? Please do let me know that you can change the entire thing. Are you guys able to understand this? Please do let me know, guys. Great, guys. Now I'll be giving you guys the attendance for today, guys. I'll be giving you guys the attendance for today. Again, it will be open till 8:30. Okay, it will still be yesterday's attendance was still open. Okay, yesterday's attendance was still open, guys. It is still open right now as well. If you have missed out the attendance, please fill out your attendance for yesterday's class. Right now, I'm going to give you guys the attendance for today's class. Give me a second. Make sure that you are filling up your attendance on time itself, but still. Responses is open, send, link, shorten, copy, link, back. Okay, so this is the link for today's attendance, guys. Please fill it out on time. Okay, I have pasted it up in the live chat and I am pinning it up as well. So what is +1 on max +1? Saurabh, I've already explained it to you guys. Okay, it goes up till 160, but 160 is also something. 160 is the max amount, right? But we want to include max 60 as well. Like 160, we want to include it into our calculations. So because whatever value that you're putting right over there, that's a stop. You're not going to include that. So we are extending it by +1. So 161, we will go up till 161. So 160 will get included. Okay, 160 will get included itself. Okay. Why are you ending each code with a semicolon? Chakravarti, I've already explained this when we started out with our data visualization itself, that if you're not putting semicolons, you will get all these messages that will come up to your screen. Okay, right over here, if I don't press this semicolon, you will get this metadata also on your screen, and you don't want this. Okay, you don't want this. What is this? Matplotlib.access, subplot, access, subplot as blah, 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 blah. You don't want that. To make sure that you are not seeing that on your screen, you put up this semicolon at the end, so Python automatically removes that statement and you're just getting your plot itself. It's just getting a plot itself. What's the difference between Seaborn and Matplotlib? So Seaborn is like a scooty, an electric scooty. Okay, very easy to operate, very easy to run. Okay, and Matplotlib is basically like a full-blown aircraft, like a military-grade aircraft itself. Because you have thousands of buttons inside of it, billions of parameters that you can change inside of it. So it's very easily customizable. It's easier to learn Seaborn, but most probably you will be using Matplotlib at any particular point of time. Okay. Okay guys, so we'll meet tomorrow again at 6 o'clock. I'll make sure that I'm in the office at time itself, and we'll continue from right over there. Okay, thank you so much guys. Thank you. Have a nice day. Thank you guys.